Okay, I turn my microphone off because I'm eating. Okay. Yeah, I think I realized what I did wrong yesterday. So, a lot. First of all, I can't rely on the existing node beyond the last node in my single linked list. So really the last node that is actually a node must be the one that has a next pointer that is null. So the standard previous here must exist, must be there. And then yeah, at the very least I should be able to print it. So now the last node has a next pointer that is null. So we can just check if node exists. So if this node was the last node, then we don't continue. But I'm only changing node, not iterator. That's why it's printing the same thing over and over. So I also have to increment iterator. I think that works. Yeah, this changes the PTR, the pointer in the iterator to its node next pointer. So maybe the PTR is now 0 or null. No, and now it looks weird. So I would say maybe I should, I mean, you really want to do this then, like here, and I'll not bother with this, and then just break out of it, I think. So I don't want to do this. I want to do this here. And then if not node, break. And I'll make this again an infinite loop. Now the test is at front and that is at the end, so I might as well put them in here now. Yeah, or not. Still looks better, I guess. No, I don't know. Get the node of the first iterator and then print that iterator. Increment the iterator and get a node of that. As long as the node exists, then it's not lost. It's not past the last node. So that worked. At least it prints something equal to list 0. No, come back to merging. So if we increment iterator while it was the last node, then the PTR of the iterator itself becomes null. So the way to test this now is to use last. Get node last. Yeah, I'm not convinced. Let's just try that. That seemed to have not worked at all. At 25, 74, 70. 17 and then 93. That looks like and then the rest of the list, I think. Oh, this is just the whole, the end. So we get 3 of those and then the rest of this list. What the hell? It's a new way of sorting. Okay, let's begin with removing this. At least we know what gets out of here. Let's just add debug output, I think. Lots and lots of debug output. Done learning. Debugging. Okay, so we have two lists, L0 and L1. 47 is less than 72, therefore the iterator pointing to 47 is going to be the iterator that is returned, and as you see that happened. So the iterator L1, which points to 47, will be returned. Advancing iters 1, so it's skipping 47. So now we have L1 pointing to that one, and L0 is still pointing to 72. Comparing 72 with 76. 72 is smaller, switching to L0. And a link from 47 to 72. Oh, I see what is wrong. Yeah, okay. The merging only works for a sorted list. They're not sorted. We have to sort them first. I think the algorithm actually works then. Stupid. Ja, this forgot to sort the list. Standard sort. V0 begin. Comma. V0 end. Cool. It has been has been sorted, well merged rather. Yeah, it works. Except that it doesn't, because... Oh yeah, okay. So the 3 things are still not added. You have to test that as well. That didn't work. So it did not add the 97. Let's see. So we get skipping the 85, and that was the last element in L0. And then nothing. And L1 is returned. Yeah. Yeah, okay. But that is only related to the first element, actually. So we have now 5 points to 9, points to 23, points to 39, points to 45, points to 56, points to 63, points to 71, points to 85, points to 0 still, because that's the end of this list. So we still have to make a pointer from here to there. And the reason being that whatever end we reached, the other list still has elements that we did not add, because the last element that we added is the last element in the list and has a null pointer. So my reasoning there was wrong. This is not good. We just always have to add. Yep, that is very good. Yep. So after 61, link from 45 to 61. Then we skip 61, so the 73 is now included. And then you see that 64 is less. And then a link from 61 to 64. Okay, and then we reach the end. Then we still have to append all these, and that now has happened. I think it finished. So let's remove all the debug output again. I don't need that. Okay. Now I have a small problem because I think in my design I was planning to use the previous pointer instead of the next pointer. So this merge works, but I needed to work for list that used the previous pointer. What do you think? Let's copy my comment from Discord. Or make a comment like it. Let's make a more general comment. And I do this using multi-threading. Not really, I think. But you can for the whole merge. This is just having two lists and then merging two lists. And in order to do that multi-threaded, you have to cut the list in parts first. So if you would know where the halfway element is, then you could start sorting from that point on. And then use two threads to sort the first half and the second half. Or sort. No, even that doesn't work, I think. Let me see, actually. Yeah, well, you could, but then you have to find elements somewhere in the middle, which means following next pointers. Now, if you consider that to be significantly faster than comparing elements, then I guess that would be beneficial. But I think it would be better to do this with a single thread, this merge. And I use multiple threads for sorting. Well, I was about to add a comment anyway, so which will explain it much better. So this is a test for the design of a merge algorithm, which we described as follows. Is it single or singly? Single linked list or singly linked list? How do you write conquer? Conquer. We're done with that one. Merge sort, yeah, conquer. Divide, fuck off. Yeah. Let's do that. Keep that like this. So I want to repeat everything. But yeah, on the other hand, it's just a comment that gets long. So this was my idea after learning how the merge sort works to do it like this. Where you abuse basically one of the pointers. So treat it like a single linked list, but every node has 2 pointers, so you can abuse one of them. And however, maybe I should even add the last case then. To the last case you have a B, which points to the smallest one, which is 1. And below that we just get the whole list merged. I don't know, a bunch. Four, 5, 6, 7, and 8. See, I wish, it's kind of confusing. The vertically, we get this. Maybe you should inverse sort them. I mean, if 1 points to 2, then we must use the next pointer here. But if we use the next pointer here, means that we use the next pointer in the vertical list, then this must be the previous pointer. But that pointer is basically inherited from what was the next pointer. So we just ignore the previous pointer, then all these things are the next pointers. So I was thinking, then we use the previous pointer here. But this is also next, so then in the end I have to override all the I would have to override all the next pointers with the previous pointer and then fix the previous pointer. Well, those two are in the same cache line, so I guess that doesn't really matter that much, but I'm thinking about, yeah, it doesn't really matter actually. The amount of memory bandwidth is exactly the same because the next and previous pointer are next to each other. They're just part of the same node class. So it doesn't really matter if you write to just the next pointer or to just the previous pointer or to both, because they're part of the same cache line and you read and write the whole cache line anyway. So now we are just talking about a single clock cycle per node in the list. And that's then even probably doing in parallel as well. I can imagine that it can write 2 registers in one clock cycle to the level 3 cache. Nevertheless, I'm still thinking about how I could avoid that. If it is avoidable, then maybe we should do that. So that would mean that I want to leave these pointers as next pointers. So I want to use previous pointers then for the vertical ones. So why not have the vertical things reverse ordered? So then all those things point upwards. Yeah, I mean, that is totally possible. I just have to change my ASCII art drastically. Uh-oh. I'm gonna do that though, because I just feel like it. So I want to... use the previous pointer. And then have them in this order, because it must be smaller. In other words, it's not even that different. Well, actually it is. Wait a minute. Yeah, no, they must point outwards, of course. I can never reach a 6 anymore. So we have to invert this. I must make this up and then swap the 5 and the 6. This going to become 6, this becomes 5. But why would I have it point up? Probably too lazy for that. So put it just here. Too lazy to get an up pointing arrow. So just reverse all the... No, wait. I'm not sure that makes sense though. Well, it would make sense, but then we have to sort. We have to merge sort starting at the largest one. So yeah, I guess it works, but I do have to change my merge algorithm then. So vertically now they go from large to small, and horizontally they have the original order. So you have to invert all of this. 6, 5, 3, 1. That's 8, 7. 1, 4, 2, change. Uh, 8, 7, 4, 2. And then I don't have to remember this. On the fly, I just figured out an algorithm that predicts the next number. Oops, what the hell? Fix the next pointers. So you have a B. There's a next pointer still pointing to 8. That has to be fixed as well, because that is now becomes a previous pointer. But now we have only one. So previous must become next here, and then next must be pointing to that. Oh wait, I don't want to traverse this again, but probably the large merge should also give me then the endpoint. Otherwise we have to run over the whole list just to find that thing. Is there another way to get to the no, there is not. Well, I could continuously update it maybe. If you just want to, if I want to have a circular list already, I could have 1.2b and keep that in a loop as being simply the smallest. Consider b to be smaller than everything else. Let's see if I can do that. Yeah, so this B we leave alone, but the last B is then considered to be the smallest, which means that here we get okay, so here we merge 2 and 4, and then B is left, and since that is a single list, we don't do anything with it, which is not very explanatory then. But maybe later on it becomes more clear. Nope. That just stays a single list. And then, yeah, okay, that would be super annoying. So now we have to merge this list with that list, where B is the smallest. So what happens is the oh, B is smaller, link 1 to B. That didn't help at all, clearly. But yeah, you have the same problem anyway. If the list is 17 long. Or let's say, let's make the list 15 long here instead of 7 long instead of 8. And then we can include the B as the smallest one. So I want to get rid of 8, say. Oh, and then I have to rewrite everything. Yeah, I'm sorry. I think I just. I think the examples are a bit too short to be really clear. But I'll generalize it at the end for a single step, and otherwise the comment becomes ridiculously long. Anyway, we're going to remove the 8 here. Okay, 6, 5, 3, 1, 7, 2. And 4. Sorting those first to get 5, 6, 1, 3, 2, 7. And 4. And those lists are pairwise merged to get 1, 3, 5, 6 and 2, 4, 7, which are again pairwise merged to get final result. Okay. However, in the linked list, you don't want to traverse all nodes to find the nth node to split the list in two. Instead, we just start at one end and collect all elements recursively in the same way. Of the first step, we can link the elements as follows. Where I have to remove the 8 because the 8 is now gone. And then so we did here merge here 5 6 or sort 5 6 whatever, and then the 3 1, and the 8 is gone. So next is 2 7 or 7 2, and 7 must stay at the top. So this is gone. I want to have the 7 here, which means I want to have an arrow here, and then the 2 is gone, and the 2 is now here. Yep, so we have 5 6, 3 1, and 2 7, and a 4. And then the next step is, so this was 7, this is 2. Well, this step is no longer there. Well, actually it is, because I'm going to treat B as an element. The smallest element. So So then merging this means So that merged away the 3 and the 1, and the rest must stay the same. And I want to keep them more at the same place. Okay, I guess I need an arrow, 2, 3, something like that. I don't know, maybe this. This just merged the 6, 5 and the 3, 1. And now we're going to merge the last part. I think I just have to start over. Probably easier. So this one is 4, and then we get 2, and then we get B. And then at the end we get all of them. And this is not what I wanted. Shit. No! I wanted a pointer to 1. Yeah, well, you can do that. I'm just gonna make a very special case of the last element. That's special case it anyway. So we'll use, you'll have to point it the other way here. Hopefully that is gonna work. Maybe I'm just stupid. I think I'm very stupid. Yeah, I just realized that that all of this was not necessary. No. And well, for the following reason, if during this step we have to traverse the whole list in order to fix all the previous pointers. So we can just start at 8 and then fix the pointer from 7 to 8, and then follow this pointer, and then follow, fix it, follow, fix it, follow, fix it, and so on. And then we reach 1 anyway, because we have to fix the previous pointer of 1 anyway, and all the previous ones, so that the traversal is not a problem. the final traversal. Hence we find 1, and then at the final step I can link B to it, because we know that it is the final thing. Yeah, okay, so this is not necessary. I think I'm going to undo it and add A back, because let's see, yay for undo. What is in the middle? Is that set? Forgot. Yes, it was set. Yeah, I think that this is it. Poo-poo. To make a long story short, I have to rewrite my merge, because now it's merging using the next pointers from small to large, and we need it to merge. We need a linked list to be a linked list from large to small, using the previous pointers. And I'm gonna do that before I fix this comment. Let's fix the comment that is written for merge. Oh, that doesn't work. Sending, yeah, that's correctly. Nah, it's just one page, but it wasn't easy. So how do we reverse this? I think that, well, it's probably easy, because I just have to change next into previous and inverse the order. So change less than to larger than, right? Yeah. And change smallest into largest, I guess. Rip. Let's first check there's no large in here. Large. I don't see it highlighted, so it's not in here. And then we substitute smallest and yeah, with largest. That should do it. And then we can change the comparison. So here we say initial largest. Index into iterator that we will put the largest iterator into. I guess I have to sort these then. So if 1 is larger than 0, then 1 is initially the largest. Yeah. So then indeed we get here, I mean they are assigned like this. So if largest is 1, then iter's 1 gives us L1. And that is then also indeed the largest iterator. And I have one other compare here, which is probably exactly the same thing. Comparing it like this, so largest means swap 0, 1 on this side and 1, 0 on that side. And then finally we must use not next, but we must use previous. Pointer at least. So that should do it, right? And then we have to call merge in the correct way. Because now that must point to the largest one. So really we must begin at the end. And then decrement L0. The first one points actually to the last in the list, which is no. Wait a minute. They must be sorted ascending, so I just have to. The sorting is wrong. You must go sort them like this. And then the first element is the largest element now, so this is actually correct. But the previous, it's still, I still want to at the end. So we must set previous, so this must become change previous then. That's the only change, I think. Yeah, and anyway, I still have to fix a dump single linked list. Let me first do the change next. Change next. So the new previous. Change next. There's no change next. Used anywhere else. Get the node. Previous is previous node. Previous becomes the past previous. Return the previous. Change previous. Now returns a previous value, not the next value, which we can ignore. There maybe is such weird, but definitely unused. Okay, and then the dump single linked list. That it still works. It just prints large. No, wait a minute. I do plus. We use the next pointers. I have to use the previous pointers. So I'm getting something. The first element is the largest. Yeah, and then we have to use the previous. Yep, this should work. And then still it prints it, of course, from a larger number to smaller number. This is and we broke it. There's even a new element out of nowhere. Okay, well, the input is correct. That is from large to small, so printing seems to work. Generating as well. But the merge algorithm is broken. Why? We had it working so beautifully. Oh, wait a minute. I'm not sure if it works. Because we're not printing it. To print it in advance, I guess. To make sure that the printing works. Yeah, and it doesn't work. So the input is already bullshit. I did even a reasonable job, I think. Then maybe merge still works, but printing is definitely broken. Yeah, okay, I get it. We do use dump now uses previous, so we do need to start with the last element. So begin is still wrong. This must be end. Oh, I could use a reverse iterator. No, I'm not going to do that. So this is end. And then we must do minus L0. Now it points to the last one. That's what needed, otherwise you can't follow the previous pointers. And then it's the begin thing of the list that must be set to null. That makes a lot more sense. So L0 now points to the last element, and the previous pointer of the first element of the list, which is the last element of the linked list that uses the previous pointers, is pointing to 0. And what was it? What I forgot? I forgot something. My subconscious tells me you forget something, but it doesn't tell me anymore what it is. Yeah, I remember. Ta-da. Seems to work then. Ta-da. So this is the original list, which is just normally sorted from small to large. Then our singly linked list using the previous pointers prints it in reverse. From large to small, and then our merge doesn't look good because it has not enough elements. But hey, it goes from large to small. 51, no, this is no, something is very wrong here. We should have, then that moment where the merge function worked and I said, let's remove all the debug output because we won't need that anymore. Never delete debug output. Comment it out. Take it from me. I've done this more often. Including deleting debug output, which then later I needed anyway. I do not understand it. Which unfortunately means that I have to add all that debug output back again. That was quite a lot. I don't have a backup of it or anything. It is even hanging there. Apparently the advancing is not working because we end up with a 5, which is the size. So we went the wrong way. Pop, 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 pop. Yeah, the plus here should have been a minus minus. And that's probably everything. Oops. No, it works, of course. So we should get 10, right? 1, 2, 3, 4, 6, 7, 8, 9, 10. 10, 10, yeah. And it is descending. The stupidness. Having to add all that debug output again just because I forgot to change the plus plus into minus minus. And nobody told me. What are you guys doing? I don't dare to delete it again. It's really bad. Yeah, I'll just comment it out, I think. At some point I'm going to delete it though. Once everything works, the whole merge. Or I could just save it to Git. Probably good enough. Oh yeah, I can get it back. Good. So now we have, where is the comment? Here's the comment. Mhm. I'm not having stored enough arrows. I need a double arrow down. Just point at it from above. So afterwards you still have a P, which still points somewhere. And you have an X, which is now possibly pointing to B. Right, I think that sums it up. And then repeat, rinse and repeat, and then you have it sorted. So this should be rather easy, really easy to finish now. The only thing that is left is, well, to write this routine, of course, but that exists mainly of merging these two, and we already wrote merge, and finding out what P needs to point to initially. Let's see, the very first step is, of course, having merged the 6 and the 5. Okay, so P must point to B initially. Yep. Oh boy, that no, I will use B twice. There's not a cursor for it. Just in a loop. That's what I meant with really easy. P and X, the next pointer of X, and P point to the same object, which is returned by merge, which returns the well, it returns an iterator, but whatever. Pointer or the get node. Use get node. Or maybe P should be an iterator. Let's do it like that. Yeah. So when is this thing done? We're done when we are left with a single list, which means that we end up with something that looks like this. But I'm pretty sure this was updated as well. It's updated here. So this must also be updated then. Yeah, must point to so if the lists 8 and 4 are merged, then the end results also must still point to whatever here 4 was pointing to. I forgot to add that. So it is relevant what D is pointing to. Okay, let's write that. Might as well. Might as well make it recursive. So this performs a single step and then calls itself unless P is already sorted, which means if P next did I change the base? I don't think I changed the base, did I? I mean, we changed the previous pointer of begin. That's it. And then we change only the previous pointers during merge of everything in the list, but B is never in this list. B is just on its own here, the begin and the end. So B is still completely intact. Therefore, we can simply detect if P next points to the base by, because I don't want to pass a list. Well, eventually this is maybe going to be, this is of course going to be a member function of the list. So we do have the list actually. Yeah, and then I would implement it differently. But I want to implement it right now in this file, and then I don't have the list, I guess. So I have iterator. My iterator has, it's derived from const iterator, which was the whole reason for this thing, an isEnd. Other containers don't have that. So I can test if this iterator is the end iterator without having the list. That's what I wanted. That's why I wrote this list. So let's just use that then. Now I'm not sure if this works, because next is a node. I can't even access next. That's bullshit. So P is an iterator pointing to D. And this is the next pointer. So if we do next, then we get an iterator that points to Y. And if that iterator is the end, then we are done with this loop. Which means that we still need to convert this list into a real doubly linked list again. But I'm gonna deal with that once I put everything inside the list itself, not in this file. So I will just consider us to be done in that case. Just return. Yeah, let's do it recursively then. So and if that's not the case, we're not done, so then we have to do this line. Yeah. So merge returns an iterator. List. Oh, wait a minute. That doesn't work. As usual. It's my own merge in this file. Returns an iterator. Yep. And then we can assign that to P, and then we get the node from that, which then X must point to. And we can do that because X is a node pointer. So I have a node pointer X, which is what P is pointing to. And then C and D are the, again, next and next. Yeah, and then when we're dealing with it that way, isn't it the case that if we are done, like really, really done, this is done. I think in this case, what is P pointing to? I think P is pointing to B. This B, but those B's are the same. Isn't that true? So in this case, so P is pointing to 6, and now we merge these two. No, in this case, we're going to merge 6 and 8. So P is pointing to B here already. Yeah. And now we merge these two, and then P is going to point to 8. I think. It has to point to the merged list, yeah. But B is still pointing to the same thing. So one way to detect that we are done is when C, but the P points to 8, so B is now C. And then the next pointer of that is D, is again this thing. So if rather we are done when D equals, sorry, when D equals X. Confusing. Okay, so this is B and this is B. And then we begin again. And I'm getting C. So C is B. And then we get D, which is the next pointer of C. That is again this one, which is X. So X equals D. Yeah. Instead of testing this, I'm going to return if X equals D. I think this should work. Okay, so we're done with this part. I now want a list that simply copies from input. Not a vector, you can directly copy it from it. Yeah. So let's make a list, copies from input. Just random stuff. And then we call merge sort. With an iterator p, where the iterator p, well, whatever, p is equal to the list end iterator. That looks weird, but yeah, it's because the list is circular. If you dereference the end iterator, you just get a node whose next pointer is begin. And I can rely on this fact because I wrote the utils list myself. So it's just how it works, period. Of course, this is not true in general. Not at all. Maybe sometimes, but... So literally we want end to be an iterator that points to base node. And check that. What do you want list here? That returns an iterator which is derived from const iterator, which is then constructed from the list itself. So this one, and yeah, then you get an iterator where the pointer points to the base node. So it's exactly what you want. We have to recursively call p. Now it's done. I hope. Okay, so test. You have to print the result. It would already be nice if it returned, but afterwards we end up with I think a list that still has a begin iterator, and that iterator is then you can do dump list. Sorted. So since begin returns the next iterator of the base node. So we have the situation now in the end that this is B. The next pointer then points to this node. So begin is an iterator. Actually, begin is equal to P, so it's just now the iterator that points to the first node. And then we call dump, which uses the previous, these are the previous pointers, until one that terminates with a null. So it's still in a weird state. It's not really list, you cannot print it as a normal list. And since we begin at the end, it's going to print it in reverse order. this way. But okay, I'll just add that even. Please let this work. Doesn't even compile. What was I thinking? Oh, merge wasn't two iterators. Oh, yeah, of course. Merge was once iterators. Hello, Zach. I wouldn't know. I don't know JavaScript. Why would you want to learn JavaScript? Well, there are languages like C++. Yeah, it needs to be iterators. Okay, that sucks. Nah. Only if you, I disagree. It's just knowledge plus, I mean, writing a program is difficult, but it doesn't matter what language you use. So if you use a language that is so simple that you can only write simple programs with it, then I guess it's easier. But then what if you want to write something difficult? If you would write this sorting algorithm in absolutely any language, it's still the same hard work. Because you have to understand, well, you have to understand this. This is just English text. Yeah? This describes how my algorithm works. And there is no C++ inside here. It's just English text with arrows. That's the hard part. And then the code is just translating this English algorithm. I mean, you can do this in JavaScript, so it's gonna be as short. It's a merge sort, but then I hammered it on it a bit to make it work for my linked list. Okay, well, so this must be an iterator, period. This must be an iterator. Which means that this is just standard next of X. And this is standard next of C. And X is simply P, so we don't need X anymore. And then we can do here P equals D. Yep, and then I have to adjust the next pointer of P. What? The next pointer. Yeah, how do I do that? Link, change a link. Change a linked list. Yeah, I can't really do that. I just want to assign the next pointer. So then here you really have to call get node on P and then change next pointer. No, I'm not too sure if that works because we changed P here on the fly as well. So this changes P first. And then get a node of that and then assigns that to I used to know this, you know, there's a certain order in how things are being evaluated. At some point I studied memory order, right? So then I really knew in which order stuff was evaluated, but I cannot recall it. If it is defined in this case. What do you mean happened to my voice? What do you mean? Now you make me worried that my actual voice is sounding weird. In which case I would have a cold or something. Or a sore lungs and I'm almost dying. Or is it something technical? Just connected. Test. Can I hear myself? Nope. Is it this one? Yep. Testing 1, 2. This sounds perfect. Doesn't it? Is there something wrong? Testing 1, 2. Okay, I'm just going to stop the stream.